Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to NPTEL online certification course on research methodology for planning and architectural studies. In our last lecture, we have discussed in detail about the parametric test and how we can use it and when to use it, because sometimes you may get the data which is not really fit for the parametric test. So for that, we have to go ahead with the non-parametric set of tests available. Both are equally important. It is not that if you fail to perform parametric tests, that means you are missing something. So it's all depends on the data type that you have collected, and based on that you take a call on whether you go for parametric or non-parametric test. So today at lecture number 38, we'll be discussing about the parametric test. I'll also tell you about some of the very prominent non-parametric tests that we use in our research in planning and architecture. So with that, let us start today's lecture on non-parametric test. What will we learn from this lecture? As already I have mentioned that we'll mainly discuss about the non-parametric test available for doing research, and then we also discuss about advantages of non-parametric test in that context. I'll also give you some of the example of non-parametric test, and then we'll summarize our understanding on it. Now, we started discussion with parametric test, and I hope that you have gone through that presentation and you understood when to use it. Now, let us focus on the non-parametric test. So, the main advantage of non-parametric test that is it do not depend on the distribution and usually applicable for nominal and ordinal data. We have discussed quite often in various lectures that type of data that we have, like nominal, ordinal, ratio, interval data. So normally for ratio and interval we can very easily go ahead with the parametric test, but when it is a categorical variable and the way we have collect the data, they are making some sort of sense of order. So basically we are talking about the nominal and ordinal data. So for such kind of data set, if you have in your survey or in your research plan that you are going to collect the nominal or ordinal data, then probably this is the best way to go ahead with the non-parametric test. For example, chi-square test, Spearman rank correlation test, Wilkinson test, Mann-Whitney test, Kruskal-Wallis test, Friedman test, and there are so many. So as I already mentioned that in statistical world you have so many options to analyze your data, but it is our researchers' duty that to pick the right one which can convey the result effectively and can convey the true meaning of the data. So in this lecture definitely we'll go through some of them. Now let us understand the advantages. As already previous slide I have mentioned that no distributional assumptions are required for conducting non-parametric test, and for that it is something that where even your data do not meet the normality, you can easily go ahead with the non-parametric test. In terms of robustness, non-parametric tests are often more robust in the presence of outliers. Maybe whenever the sample size is small, and mainly we observe in some cases that the sample size is low, and for that reason it is not really following any normal distribution or any other some sort of parametric distributions. So in those cases it is very effective to go ahead with the non-parametric test. Non-normality distributed data. So non-normally distributed data, as I already mentioned that say you collect information where you assume that probably the data should behave normally, but it is not. Depending on the field, nature of the questions, definitely the distribution of data will be decided. It is not like in our hand, though there are certain sort of set rules, as say for example, like when you compare the marks of student in a particular subject in a class, so normally you may expect a normally distributed grade, but maybe when you go for surveying, say, number of cars on a particular stretch of road, and you would like to understand their average speed, so maybe there also will get some sort of distribution, normal distribution, that okay, very few probably will have very high speed, very few will have a lower speed, and there will be some average speed that most of the vehicles they are maintaining. But it is not universal that all the time we'll get all those kind of data which are normally distributed. So for such cases, definitely non-parametric test can be used. And as already mentioned in earlier slide as well, that for categorical data like a nominal data or ordinal data, where the data represents some sort of order, we can simply go ahead with the non-parametric test. Now here are some examples and what they do. I have tried to summarize it in this particular slide. So chi-square test is a non-parametric test which examines the association between two categorical variables. Now, whenever you have some sort of data set and then you have certain sort of frequency or maybe certain numbers. So in chi-square test, we'll see like in upcoming slides that how we normally perform this test and how we compare it. So there would be some sort of expected frequency, or there is something which is actually measured. So it is just measuring that kind of estimated result and the actual result, and then we try to capture it. Spearman rank order correlation, this is another good non-parametric statistical test which can compare the rank order of two groups. So whether they are really talking something different or there is some sort of strong association. Mann-Whitney U-test also compare two independent groups, and also we have Wilcoxon sign rank test is also compared the two related groups. Kruskal-Wallis compare more than two independent groups. So in parametric test we discussed about something, we mentioned about something called analysis of variance, ANOVA. So this Kruskal-Wallis test or the Mann-Whitney U-test, they are, maybe you can say, a comparable one. So they are also doing the same job the way ANOVA used to do for parametric test. Then the Friedman test compares more than two related groups. So these all statistical tests are available, well established, people are using it. There are n number of papers available where they have successfully demonstrated the use of this test. Now the next point is that each of them, they are having some sort of theoretical assumptions. So as because the focus of this lecture or maybe the course is not to go deep into the statistical analysis and all that you may find in some books, and I'll also give some references for this particular lecture so that you can go through some of the literature, go through some of the books available where you can get insight about the steps that are followed for all this method. These are also very well established statistical tests which are available with all standard statistical packages like SPSS, or maybe you can use Rata, or maybe even if you want to do your own programming in R or any open source language. So in this particular lecture I'll be focusing on two very important non-parametric tests. The first one is chi-square test, and then I'll also talk about the Spearman rank order correlation test. So the equation looks like this. So this is basically we refer as a test statistics. So we calculate it based on the data, and then we'll compare this calculated test statistics with the critical value. So for all such kind of tests, there are established table. It depends on the degree of freedom, level of significance. So those things I guess that by this time you are clear about it, that we discussed during the distribution as well, the hypothesis related PPT. that if it is say something like 95% confidence level or 5% significance level, what exactly does that mean? And then finally we take the corresponding value. So here also we are following the same. So there are established chi-square table based on certain degree of freedom and also the significance level. We pick the critical chi-square value and we compare it with the test statistics, and then either it is greater than or equal to or less than, we take a call on the hypothesis. We'll come to that. Now, what exactly it is, let us understand this nomenclature. So here you have like chi-square on left hand side, and right hand side it is sum of, you can say, this OIJ, which is observed frequency of any ith cell. So we have a series of data, and then we also calculate the expected frequency of the corresponding cell, and then we take the difference, the square difference of that, and we divide it by this expected frequency, and based on that you just try to find out the sum over this particular ratio of the square difference of observed frequency minus expected frequency, and then divided by the expected frequency, that we sum of that. Now how to calculate this EIJ and all, so I'll coming to that. So for this particular example, like I'm taking a case, hypothetical case, the values are also hypothetical. So this is a table where in those row we can see that we distribute the settlement into category, slum and non-slum area, and then we are interested that is there any sort of relationship that slum and non-slum with the water connection. So have water connection or no connection. So here are the figures that slums having water connection 25, no connection 30, non-slums 30 household they are having the water connection, and 15 having no connection. So apparently if you see this particular data, you can say the non-slum area they are having better connectivity, right? But we try to investigate more. So where the total connection, if you see that the row total and the column total is 100, fine. So now we formulate the hypothesis here for this particular purpose. So the null hypothesis in this case, we consider the settlement type, which is slum or non-slum in this particular case, and having water connection are independent. So that like to state that there is no such kind of relationship, that it will not depend on the slum or non-slum to have a water connection or no connection. Alternate hypothesis, settlement type and having water connection are not independent. So that means it is basically dependent. So what we now conclude, say maybe apparently, that non-slum area they are having better connectivity. So maybe after calculation and all, we will look into that result, that whether our assumption is correct or not. But to check it, we have to formulate the null hypothesis, where in this particular case we say the settlement type and having water connection they are independent. So there is no such kind of relationship, and alternative is just the opposite of that. Now let us go ahead with the table. Now these are observed value, already it is the same table we start with. So now we will go step by step and we will follow. Now in this particular equation, in the numerator and also in the denominator, we have EIJ. So how to calculate the EIJ? So it is nothing but the row total multiplied by column total by grand total for an individual cell. So let us understand. So this is basically you have the total, this is row total 55, this is column total, this plus this and this plus this, which is 55. So now if you try to find out the EIJ for corresponding cell, let us understand how to do. So this is the grand total. Now for the corresponding value, this is nothing but the OIJ value. So these are all OIJ. So I and j refer to the column and all. So say for example, this is 1, this is 2, this is 1, this is 2. So this cell is referred to O11, this cell is O12, like that. Now Eij or E11 will be 55 by 55 divided by 100. So this is the figure. Now for next value, which is corresponding to the non-slum, so in this case definitely your row total will be same, but column total will now be 45, right. So then the corresponding value you can also calculate at your end and then can match that it is 55 into 45 divided by sum total 100. So this is 24.75. So accordingly I calculate all of them. Now you can see a difference, right, where observed frequency for O11 is 25, but E11 is 30.25. So there is some difference, right. So now we'll go for that calculation. So here for your like understanding, I keep both of them with a comma in between. So the first one is the observed and then it is the expected, right. So like that you have two set of information. Now these are the difference, somewhere you get the minus, somewhere you get the plus, so positive and negative. Up to this it's okay. So basically in this table we are calculating the difference, the numerator. Next part is that we have to make the square of it. So we simply make a square, and whenever you make a square of any particular number, so even if it is minus in actual, but the square value will always be positive. So like that we have calculated the square. Now next thing is that whenever we have those values, we have to also divide it by Eij. So this is something now you have to take a call. So these are the values you have for y minus ei square, ij square, and then this is divided by Eij. Now in this particular case you are getting a value, okay, in 4 respective cells, right. So for this equation we are getting 3 values. So I just represent like x1 plus x2 plus x3 plus x4. So where x1 is that the result at 0.91, then x2 maybe this one, x3 this one, this is x4, and then we take a sum total and the chi-square calculated value now to be 4.5. Done. Up to that it is all okay. Now for degree of freedom, because now we have to calculate the degree of freedom and we have to check the corresponding critical value from the chi-square table. So degree of freedom normally calculated by column minus 1 multiplied by row minus 1. Here we have 2 columns and 2 rows. So 2 minus 1 into 2 minus 1, so 1. Next task is that from chi-square table, which you can easily download, from there we have to find it out at degree of freedom 1. So this is the value, and then here we are trying to see the statistical significance at 5% significance level, or it is the value should be taken like 0.05. So this is 5% significance level. So the value is 3.84, and what was our calculated value? 4.50. Now here the chi-square calculated is greater than chi-square critical, because 4.5 is higher than 3.84. So whenever it is higher, the condition is that we have to reject the null hypothesis. So that's what the decision. Now what was the null hypothesis? If we just try to reconnect, the null hypothesis was there that there is no sort of relationship. So we reject the null hypothesis and accept the alternative hypothesis that there is a significant relationship between settlement type and water connection at this level. Okay. Now I will show you again our two hypotheses. Settlement type and having water connection are independent. Now we are rejecting it. That means they are dependent, right? Now if you recall, we just assume that probably the non-slum area, they are having better connectivity compared to slum area. So that means we try to put up some relationship, and that actually has come now. because in this particular case what we have seen that based on all these test statistics calculation and comparing it with the critical value, we have to reject the null hypothesis. Okay, hope this thing is clear. Definitely you can go through some of the more examples, and I'll also provide some of the practice example or something that you can practice at your own, and we can discuss it in the forum. Now coming to the second one, which is known as Spearman's rank correlationship, which is represented by rho s, which is like 1 minus 6 sum of the difference square and then n multiplied by n square minus 1, where the rho s is Spearman rank correlation, d1 is the difference between the ranks of paired observations. So here always we take two pair and then we try to compare the rank, not the actual value. Now n is number of observations. Now it may happen that the ultimate value is like it can vary from +1 to -1. So whenever it is +1, that indicates perfect monotonic increasing relationship. That means it is highly related, that if the first group increasing in some case, so the second one will also increase. If it is -1, it is the reverse relationship. If one increases, the other decreases. And whenever you find something like the correlation as 0, that there is no such relationship, right. Let us understand. So in this case I picked up some architectural example. So there are 5 buildings, building A, B, C, D and E, and we measure the height. Like for building A it is 18 meter, then 15 meter, 10 meter, 25 meter, 20 meter. And then we also try to give some sort of historical significance in some sort of ranking. This is again a hypothetical case, definitely, but here we just try to understand that okay, building D is the first one, then building B, then like that building E, and these are some sort of significance. Now these are the raw values, one is in meter which is in height and the other one is just a score about the historical significance. Again it comes on this particular decision on null hypothesis formulation and alternative hypothesis. So null hypothesis in this case that there is no monotonic relationship between building heights and historical significance, that there is no relation, okay, it is independent. Alternative is there is a monotonic relationship between building heights and historical significance, right. Now let us go ahead. So this is the overall formula we need to remember. In this case n is nothing but number of observations, so here number of observation is 5. So the denominator we do not have much complicated calculation. Now in numerator you have the difference, okay, di square. So di we have to find it out. So what you need to do, from the height data of all the buildings we have to rank, okay. So in this case if you just compare, 25 meter was the highest and then 10 was the lowest, accordingly you can find these are the rank given, okay, and rank given in such a manner that the highest height will get rank 1 and the lowest is which is having the minimum height among this data set, and this is the data, and already we have some sort of historical significance rank. Now we compare, we just find out the rank difference. So here it is -1, here it is -1, in these two cases C and D there is no such kind of difference, and overall if you make a summation this will give you 0. So we do not need that one, right. So that is why we actually calculate di square, not the di, sum of di will be 0. So this is some kind of cross check, even if you do it manually for a shorter manageable example. So this is something you always remember, you have to take the square of the difference, fine. So square of the difference will come into the next slide. So this is the difference as previous and this is the square difference. and then we take a summation, so which is 6, then we have to multiply it, so that will be 36, and now the calculation for the new denominator, 5 into square 25. So 5 is nothing but the number of observation, in this case it is 5 buildings are there, so 120. And we finally derive it like the relationship or this particular coefficient, rank order, Spearman rank order correlation coefficient as 0.7. Fine. So this is calculated state statistics. Again we have to compare it with the critical value. So again we have to refer a table. So in this case the number of observation 5, so we have to take that value, and also the 5% significance level, the value is to be taken corresponding to 0.05, so the value is 0.9. So what happened in this particular case? Earlier case our calculated value was 4.5 and it was more than 3.8 that value, but here it is actually less than that. So for such reason, as because it is less than the critical value with given set of observation and the significance level, then we fail to reject null hypothesis. If the calculated value, suppose like it would be more than the critical value, then we could simply reject the null hypothesis. But in this case, as because it is low, fail to reject null hypothesis, and for that what we conclude that there is no monotonic relationship between building heights and historical significance. So basically it is something like you are accepting the null hypothesis, but in a conventional way we do not say accept null hypothesis, we always say fail to reject, okay. So which is indirectly like accepting the null hypothesis. So hope this is clear to you. The calculations are very easy, and whenever it is like very few number of data points, it is very easy to do. But one thing you should remember, that in this case we compare this value with 0.9. The reason that okay, this is the numbers like total number of observation is 5, okay, but there is also a particular influencing aspect in this, that is nothing but the significance level. If you increase this value like from 5 to 10, so you have a broader acceptance. In those cases, like definitely if you can see that the value is reduced to 0.8, even if it is not making any change in the decision for this data set, but there may be, if you go with more precise data like 99% confidence level or 1% significance level, then you have to compare it with the value of 1. So studying the table, referring the table correctly is equally important like the way you calculate the data. So with that we summarize this particular lecture. So we discussed about non-parametric tests, which are much more applicable for categorical data, nominal or ordinal data type, and also we have discussed about the advantages that it is distribution free, the data may not be normally distributed to take up this kind of statistical test, and also like for a smaller sample you can very easily use it. And we have discussed here the chi-square test and the Spearman rank order correlation test, and there are other many as well. We discussed about the Mann-Whitney test, Kruskal-Wallis test, etc. So go through all such kind of tests. You can also study little more on the statistical test and all, and then if you have any doubt you can always post in the forum. I'll be happy to answer to best of my capacity. So these are the further books. In those books also you'll find some chapters on this parametric and non-parametric test as well. With that I conclude this discussion on parametric, non-parametric. Now we'll be moving towards specific module on quantitative research approach and then the qualitative research approach, and I'll show you some of the applications, some of the case studies, some of the papers which are accepted in good journals. So through those papers I'll try to demonstrate the type of quantitative research approach most frequently used in planning and architectural research. With that, thank you once again for joining and participating in this course. We'll be meeting soon. Bye bye.